I'm Diana, and you're watching Physics Girl. So, I grew up in Hawaii, on the island of Kauai, which is the oldest of the main islands, the wettest, the greenest, the most beautiful. It had no nightlife. There were 22 kids in my graduating class. Ugh, I digress. So the Hawaiian Islands are geologically weird. They're formed by volcanoes, we know that. But wait, scrap that. They're formed by volcano. Just one. It's like an upside down chocolate kiss conveyor belt. There's a hot spot that forms the volcano, and then the plates move over the top, making the islands one by one. Bloop, bloop, bloop. Now you know. So, one of my childhood friends, Noah Randolph Flagg, became a geologist at UC Berkeley. And when we were back home over the holidays, we went for a hike and got talking about how unusual the formation of the Hawaiian Islands is. It all started with a mystery.
World War II, the US military was looking for Japanese submarines in the Pacific. And the way they did that is they'd lower a magnet off the side of the boat, and the magnet would get pulled down if there was a metal submarine under there.
The military mostly used planes with these magnetic contraptions, but scientists later adapted the technology for boats.
And well, presumably they saw some submarines. I don't know about that, but what they also saw was the magnet would go up and down sort of periodically on the ocean floor. Sometimes it would pull really hard and sometimes it wouldn't pull very hard. Do you have a thought on why?
This was the mystery. This magnetic contraption was made in wartime to search for submarines underwater, but something else was pulling on it. Something unidentified and deep underwater.
I'm gonna guess that it had to do with how much magma was close to the surface of the ground, and because there's more iron, I'm guessing, in that rock, then it pulled harder?
You're totally right. It's about well, you're totally
Noah's brother Jeremy, who's also a geologist, just told me that I'm not totally right.
You're totally right that it's about the iron
Jeremy.
in the rock. If you imagine a molten rock as being a bunch of little magnets floating around, what direction do you think those magnets would align?
I would imagine that they would align along the magnetic field lines.
Excellent. Okay, so we have all of these magnets in the molten rock that align with the Earth's magnetic field.
Yeah.
And then they freeze and they're stuck there.
Oh, okay, go on.
And the Earth's magnetic field would reverse. And so what they were seeing was these stripes was the reversals of the Earth's magnetic field. And
what?
yeah.
What?
Yeah. And the other thing they noticed is across the Pacific, it's symmetrical. It looks almost like a barcode.
Yeah.
But it's a symmetrical barcode. And they're like, well, that means that all of that crust is being produced in the same place.
And this is how we learned that the Earth even has plates. It's the #1 thing you learn in Earth science.
Tectonic plates!
And we figured it out because these lines of little magnets aligned with Earth's magnetic field as it flipped over millions of years and then was frozen into the rock. Amazing. The vast majority of volcanic activity on Earth occurs along plate lines. And that makes sense because if you're gonna spill your guts, you're more likely to do it along a seam. But there's one glaring exception.
Hawaii is dead in the middle of a plate. Plate tectonics doesn't explain a place like Hawaii. So that's sort of a problem. So what people call on is this theory called mantle plume theory. And the idea, right, is so thermal convection is hot stuff is less dense, cold stuff is more dense. Cold stuff goes down, hot stuff comes up. So you imagine convection as the boiling of water on your stovetop, right? Right. In the Earth, that convection is happening in solid rock. Yeah, so we're talking about motion of solid rock, right? Because at those time scales and at those length scales, the ground, the solid rock that you feel is as viscous as the maple syrup that you're pouring.
That's amazing. So this is rock moving through rock.
Yeah.
Wow.
So if you scale things the way that we think that they scale, it looks like a lava lamp, right? You have some hot stuff rising, and it starts with a big blob, and then there's this long, skinny tail behind it. The same physics happens in like nuclear bombs, right? You know, the mushroom cloud is the same idea, right? There's that big buoyant plume, and then the tail, the skinny tail behind. So the idea is that Hawaii and the Hawaiian Islands and these other hotspot volcanoes are that tail.
Hold on. So, this mantle plume theory says that an unusual hotspot like Hawaii is just the tail end of that blob shape of solid rock rising through solid rock. That's it.
So then you might ask, well, where's the
bubble?
Where's the bubble? People have argued is that those bubbles are these things called flood basalts. This is good, I promise. This huge bubble just explodes onto the surface, and so most of Siberia is covered in lava flows, and most of India is covered in lava flows. Individual lava flows that are hundreds and hundreds of feet tall that cover an entire country.
Wow.
And
so that was, I mean,
that's
like,
the thought is that was the bubble.
Bubble exploding?
Yeah,
or?
that's that bubble exploding into the surface. This is the tail and the head.
Yeah. And then as the head gets higher and higher, the pressure is released. And that means that the solid rock is going to start turning from a solid into a liquid.
Yeah, and so that's what we call magma. And the reason it's super
have we ever seen anything like that happen?
Never.
Would it be an incredibly violent event?
Well, this gets good. There have been many extinctions in Earth history, and many of them correspond with when we think these bubbles explode to the surface. So the most recent one was 40 million years ago, and it was tiny, like a thousandth of the size of some of these. Yeah. But the largest extinction in Earth history, the Permo-Triassic, happens during the largest flood basalt.
So yeah, let's hope that doesn't happen anytime soon. Okay, so recap. The Hawaiian Islands are forming on a hotspot that's the result of one of these mantle plumes popping up through the crust like a hot pimple. You're welcome. And this might tell us something about the geology on the planet Mars.
We think that plate tectonics is not happening on Mars, but we think that probably mantle plumes are, and that's why we have these giant volcanoes like Olympus Mons.
Okay.
And part of why Olympus Mons is so big is because there's not plate tectonics, right? So stuff's sort of piling up in the same place. But in Hawaii, because the plate is moving, you get snapshots. It's exactly like how your video camera works, right? Is you're taking a series of stills, and you can see the progression through time. And so what we see in the Hawaiian chain is a series of stills of the island through time. So when you go to the Big Island, that's it being born. And then you can trace that chain of islands to here, which is 5 million years. And you can trace it all the way to Japan. All the way up to Siberia.
Really?
Yeah, you go.
That is the line of the motion of plates over that one.
Yes.
Do me a favor, go to Google Maps or Google Earth and pull up the Hawaiian Islands. Maybe after you finish watching this video. Turn on satellite view and you'll see a line of old mountains traced by the same hotspot all the way up to Siberia. It's incredible, and you'll notice the line is crooked, which means that at some point the plate just changed direction, which is weird, but crazy that you can tell something like this about history from looking at the ocean floor.
So you can take the distance between the Hawaiian Islands. We actually know the ages, and you can calculate a velocity. And those are the same velocities that we measure with GPSs now. Actually see that.
That's so cool.
Yeah, it's really cool.
So there's a lot of stuff we're still learning about the Hawaiian Islands. Thanks to Noah for trying to quench my unquenchable curiosity. Thanks to you for watching. Subscribe if you want more physics or whatever we decide to get physical with. And just kidding, happy physicsing.
That was awesome.
Okay.